Welcome, everybody, to Big Solutions to Climate Change with David Kunhardt. I'm very happy to introduce David, who is a current board member of Chocorua Lake Conservancy and serves on the Tamworth Energy Committee. I know these are career highs for him, but he also has worked to form community developed partnerships for over 20 years in government, nonprofit, and for-profit settings from Boston to Washington, D.C. to San Francisco. In 2007, he began to address climate change and shifted to the finance of solar energy. In 2020, he retired as a co-founder and CEO of Sol Ed Benefit Corps, which arranged solar partnerships for schools and cities to save them money as they committed to clean energy. Since 2013, David has been volunteering for Citizens Climate Lobby, including the Marin County and Portland, Maine chapters, and the Maine chapter of the Foundation for Climate Restoration. He is also a trained climate reality leadership corps presenter. He has presented and discussed climate issues and solutions with middle school, high school, university, and social clubs. And we are delighted to have him present to us tonight. Welcome, David.
Thank you very much. It's an honor to be with you, Juno, the historian of the CLC and of Chocorua. And it's great to see several familiar faces and names in this group. Now, I am going to jump right in, but first of all, I want to reassure you that I'm not going to be talking about a lot of the current disasters that if you're reading or paying any attention to the news, you know what they are. Today, there's a biggest ever storm hitting Mexico, for example. I am going to talk about a couple of current facts because I think it's an important starting point and adjustment. But does anybody have an outrageous question for me right now at the beginning of this? Anybody? I will be happy to take some questions. I'm going to ask a couple of questions as we go, but I want to make sure that, let's see now, I want to get you guys out of the way, and I want to go slideshow from the beginning. Can you all see that? And can you all hear me?
Yeah.
And I want to make you all small, but I won't be able to see you. So as Juno said, put your questions in the chat and she will alert me to when there's something. I have been fortunate enough to be a part of the Chocorua community since 1962. And our family had a 60th anniversary celebration this summer, and we just prize that as a place for us to always gather. And let me just get right into some of the facts. This year, if you probably heard and you probably felt that it is the warmest year ever recorded by humans. This is the daily surface air temperature recording on a global average basis as reported by the University of Maine. And the golden line is last year, and the dark line is this summer. So we're off the chart as far as average temperature is concerned. Oceans are in a way even worse because, as you probably know, it is harder to heat and cool water than it is to heat and cool air. And so the oceans have been gathering the excess heat and storing it. And the amount of increase in ocean temperatures is not just off the charts, but it is leading to unprecedented things in our environment that scare me. And one of them that you may not be so super aware of because it's not daily in the news is September is the month when the maximum ice around Antarctica is supposed to be achieved and is achieved every year, year after year. The golden line around this is their typical average margin or median margin of ice around Antarctica. This September 10th, it was materially smaller because the water is melting some of that ice from underneath. On the western shore is something that has been nicknamed the Doomsday Glacier. It's the Thwaites Glacier. It's the size of Florida, about over 70,000 square miles. And this is the surface of the Thwaites Glacier. It is cracking and moving a little faster than expected. And that is marching on down to the ocean. Part of it is floating on the ocean, but it critically, and can you see my moving, oops, can you see my moving arrow? Yes, you can. Thank you, Dexter. Part of it is landed on underwater structures, and that is where the warm water is causing that to melt and causing that to be more and more fluid. If or when that glacier fully drops off, sea levels will rise almost immediately within a week or so by 2 feet to 9 feet. 2 feet to 9 feet. And think about all of the shore infrastructure that we have that is going to be vulnerable, not to mention beaches. What's the root cause? The root cause is the level of carbon dioxide in the air, and it has been measured since the 1960s by scientists at the Mauna Loa Observatory, and it has now achieved a level that is well beyond what scientist Jim Henson warned the U.S. Congress in 1988 when they asked him, well, what's the tipping point? What's the warning level of a amount of carbon dioxide? And he said, well, 350 parts per million, because it was close to that level right then in 1988. And by the way, obviously, we are now more than 50% higher than that. It's the highest level in over 3 million years. So it is something that is really absolutely unprecedented, not just for our recent life, not just in the industrial age, but for millions of years. And what does that mean? Well, for humans, human development is really, let's just say 10,000 years since after the last ice age. That's the period during which agriculture has developed. And you can see the line has gone way beyond that. I would call it safe harbor time that humans were able to develop and multiply throughout our recent history. And in 2022, we have hit a record level of carbon emissions globally. This is not the US, this is globally, over 36 gigatons, 36 billion tons. Remember that number for later on in the presentation. And you might say, and you might hear from some people, well, the climate's always changed, and well, CO2 has always changed, and over the years, yes, it has. And this is a graph that shows the remarkable coincidence of the amount of CO2 in the atmosphere with global temperatures and sea levels, all measured by looking carefully at ice cores going down several miles under Antarctica, and also looking at geologic evidence around the world. But see how there is a lot of correlation until now. And this, you've got to say, is the industrial age overshoot beyond what that sine curve of change has been. And we have very rapidly changed the CO2 concentration. And the obvious questions are, what's going to happen to the temperature and to sea levels? If we have overshot by so much the CO2 concentration, how much are we going to overshoot with temperature and with sea level? And this summer, when the really unsurvivable levels of temperature were being reached even in the US Southwest, I began to really wonder. And several scientists wrote a paper a few years ago that said the last time that the present levels of CO2 were reached, the oceans were up to 20 meters higher than they are today. That would have absolutely stunning implications for every major city around the world that is anywhere near the coast. So Now, tonight, we're going to talk about big solutions to this mess that we've gotten ourselves into. And what are they? I'm going to talk a little bit about new law and policy that has already been put in place and the evolutions of that. And then the next best steps in law and policy. I'm also going to talk a little bit about re-envisioning climate goals. And this is something for those of you who consider yourselves well-informed and well-engaged, scientific-minded climate specialist folks. I'm going to ask you to rethink some of the actual goals and also talk about some innovations in business and in other. And finally, what you can do as a citizen. Recent law, to get right into it, last August, a year ago, the Inflation Reduction Act incorporated what's been called the biggest climate bundle of climate solutions and incentives, mostly carrots, mostly incentives to us, fortunately for the first time to cities and other non-tax paying entities will be included in that set of carrots to do the right thing with respect to investing in renewable energy. And it's a matter of fact, because it is just a kick of the flywheel of the economy by adding in some incentives, many believe that the total level of investments will be much, much greater than the dollar amount that we're going to be letting go as unpaid taxes or tax credits. One commentator, Leah Stokes, said climate spending, thanks to the Inflation Reduction Act, may end up being as high as $1 trillion. The Credit Suisse said the climate economy is about to explode. And that's really around the world, not just here. More commentary on that Inflation Reduction Act. It is thought to, by some, be a generator of over $4 trillion of new capital by the next 10 years, 9 or 10 years. Not just solar and wind, but carbon capture, transportation and storage, hydrogen use as a fuel, clean hydrogen that is, and new consumer technologies. And that will represent a pretty massive consumer shift. We live and vote in Maine, and Maine has some of the most backward source of home heating. Well, Maine is also the fastest to switch to heat pumps, electric heat pumps of any area in the country, and that is a material improvement. Ironically, a lot of these subsidies are going to be going to red states. And there are a couple of different articles that have come out in the last 6 months that will have done careful estimates and said, yeah, red states stand to reap the biggest rewards from the climate package that got passed. And Texas is a prime example of that. Texas has more solar and more wind than pretty much any other state. So where do we stand now? What's in effect the starting point with our energy generation? Well, we've done a lot of good work in the last couple of decades, and we've gone from coal is the dark blue line. We've gone from coal being over 50% of our energy generation source to being less than renewables in the last couple of years. And renewables have grown steadily. Natural gas, which is also a fossil fuel, has grown the most thanks to fracking and all sorts of business innovations. Nuclear is kind of the steady as you go, 24/7, 20% of our energy generation across the United States has been nuclear, and that is likely to continue. And there's some new things, kind of exciting things happening in that line, although not very, very quickly. Now that's energy generation. Energy use on the transportation side is becoming even more important in the US as the way that fossil fuels are making their way into the atmosphere. But according to the folks at Bloomberg New Energy Finance, who've been tracking this for a long time, 2017 was the year when the last year when internal combustion engine sales were highest, and it has been steadily going down. This is globally. A lot of the electric vehicle purchases is in other countries, but almost all of the major manufacturers have promised an electric future. So it really is, we really are making a change. And yet, on the political sphere, how often have you heard leaders say, you know, I'd support renewable energy, but I'm concerned about jobs and the economy, right? That's usually the complaint. Well, I'm here to tell you that that's already changing. In 2023, these are the levels of jobs in 4 different representative industries. The coal industry has shrunk to 55,000 jobs. Wind is responsible for over 85,000 jobs. Electric vehicles, 94,000 jobs. And a lot of that has come on very, very recently. Solar, because it takes a lot of people to crawl up and down roofs and go into farms and so forth to plant the solar, over 260,000 jobs. These are existing jobs in 2023. So the economy is already tipping. The economy is already adapting. Projections by International Energy Agency of future investments, and this is 2 different cases, sort of main case and elevated case of investments in all these different areas of renewable energy is up, and up and away, if you will. Now, what is on the we've talked about the carrots and the enhancements. What's on the stick side? What's on the regulatory side? This is the northeastern states, and you can see these are how many of you heard of the RPS standards, or renewable portfolio standards? These are laws that are passed by many, not all, but many of the states and Canada, that say this is how much renewable energy we should have in our total portfolio by 2030. That's the typical goal that folks have set. And you can see Connecticut. Now, I want to get this out of the way here. Well, how do I get rid of that? How do I get rid of that? Anyway, you can see that Connecticut and Rhode Island, where they are, New York, 70%, Vermont by 32, 75%. Maine is quite aggressive, 80% by 2030 and 100% by 2050. Any guesses what New Hampshire's RPS standard is? Any guesses? Legislative standard. It's the closest one in years, but it's only 25%. Compared to all the others, we're well behind here in New Hampshire, and we're just catching up. We're just trying and struggling to catch up, and I'm going to talk about that a little bit more. So will all of these carrots and some sticks be enough to do the job of mitigating the cause? No, they won't. What more do we need? Well, here is the U.S. levels of carbon dioxide emissions, greenhouse gas emissions, carbon dioxide and methane, basically. And you can see that during the depression of 2008 and of the COVID depression, that we were well down in our emissions. But we have been gradually, bumpily going down. We did rise a little bit last year, and that's where we stand right now. But we've got to bring that down. The goals of the present administration is a 50% reduction in greenhouse gases below the 2005 levels. Well, what can make us get there? This is the estimated level that the Inflation Reduction Act and the Bipartisan Infrastructure Act and the CHIPS Act will get us down to this level of reduction. If we also add to that something that Congress is actually in a bipartisan fashion working on right now, clean energy permitting reform will reduce us down by about 40%. So that's big. And that is something that some Republicans are quite engaged on, as well as quite a few Dems. Now, the next thing that we should add, which will get us to our goal, our stated goal, is putting a price on carbon. If we also add healthy forests and conversion to electric everything and more energy efficiency, we'll have a 60% reduction. That would truly be success in meeting the huge need that we need to meet. Okay, what is this carbon tax and what is that about? Well, I often say when you've got a big problem in hand, turn to a brilliant woman. And Janet Yellen is one of many economists who have expressed what economists think is the most straightforward, get to the heart of the matter, put a price on the problem, and we will get there. Well, she initiated with a bunch of others a signing statement, and a remarkable, astounding number of over 3,600 US economists have signed on to a statement in support of a carbon tax with cash back going to everyone. This includes people from both political parties, all four current and former chairs of the Federal Reserve, numerous Nobel laureates and Council of Economic Advisors chairs, again, serving presidents from both parties. So it is quite easy to say that the consensus of economists really is about as strong as the consensus of climate scientists about what's wrong. So that's what economists have told us to do. Who are some other sponsors? Well, there are over 40 countries that already tax carbon in one way or another. Sweden has the highest price and still a very growing economy. Canada has just in the last year expanded from British Columbia to all the way across, and all of Canada is now pricing carbon in one way or another, and several provinces are doing the cash back. So they're getting over $700 per family per year in cash back. The scientific community, political leaders, business leaders have all said very clearly, tax the problem and that will address it. And this solution was endorsed by 96 members of the House in the last Congress, and one shy of the needed 50 to be included within the Inflation Reduction Act, 49 out of 50 senators, and also Citizens Climate Lobby. So who is Citizens Climate Lobby? What do we do? Well, this is an image, a real image of June 13th. I was there. I was one of the people up in that zone over there in the upper right-hand corner, who we had almost 1,000 of us, and we had 436 peaceful and calm meetings with members of House and Senate on Capitol Hill, usually with 7 or 8 of us in the room. And this has been, the Citizens Climate Lobby has been a nonprofit doing this for, let's see, since 2009, so 14 years. And it is all about building political will, teaching, coaching people in how to talk to members of Congress. It is a peaceful army, armed with respect and admiration for those who oppose us. Our little Maine delegation went with including 15 students, 10 from Baxter Academy. All of those students went into meetings with members of Congress. They were awed, and they were awesome. And it was quite cool to watch that. It's not just, let's say, the progressive wing. This is the Climate Leadership Council, not Citizens Climate Lobby, but the Climate Leadership Council, which was created several years back by George Shultz, the late George Shultz, and Jim Baker and others. And they have gotten the support of numerous major corporations. And there are all of these different economists who have come forward to be backers and founding members of that conservative, I would say, Climate Leadership Council, which backs exactly the same solution of a carbon fee and cash back. These are the 40 other countries around the world in different stages of adopting. The only major developed countries that are not there are Russia and the United States. So we're not in the best company in taking action. Now, one of the great things about the policy is that it promotes fairness. Lower income households on the average have smaller footprints, carbon footprints. They don't have 3, 4, or 5 vehicles. They don't fly airplanes a lot. They don't have multiple houses. Those who are on the bottom quintile, and let's look at this carefully. This is all households, and dark green is the households that will net benefit by a carbon fee and cashback policy. The light green are those who will have quote, a loss. That is to say, they're going to be spending more than getting from back in that cashback. But the bottom quintile or 2 or 3 are substantially getting more back than they are paying out. The higher your personal carbon footprint, the more you come out behind. But isn't that an aspect of fairness? Those who are spending the most in carbon budget should be paying the most. Is it effective? Well, carbon pricing has been proven effective around the world. This is a graph of what's happened in Great Britain after they introduced a carbon tax in 2013 on energy generation on the power sector. And CO2 emissions fell 61% in 6 years. And look at the coal is the thing that declined the most. So the air is cleaner, health levels have improved. It has been a very effective policy in Great Britain. So what is the policy and how does it work? It is a revenue neutral. That is to say, it doesn't add to the deficit because we're not putting that money into government or borrowing to spend it. We are getting the money from the companies that are digging. Yes, there is a tax on the polluters. That's where it comes from. It's not a tax on you and me. It's a direct tax on those who are pulling carbon dioxide out of the ground. And cashback, sending money out to everybody equally. Under 18 in the present bill, under 18s get half share. Everybody else gets exactly the same. With a border tariff adjustment so that we can encourage other countries to have a similar policy. If you're an economy that likes to be selling carbon intensive products into the US market, would you rather pay a fee based on the carbon content at the border of the US to the US or tax it yourself at home? You'd rather tax it yourself at home. So this is a way to make this policy really quite extensively copied around the world to the extent that others haven't already gotten one into place. So more precisely, the money comes from those who are removing carbon dioxide in mines, in wellheads, and in ports, and bringing it into the country in ports. Those companies pay into the Treasury. The Treasury turns around and writes checks for everything except for the cost of the paper to make the checks out to individuals equally every month. And the increased cost of carbon, because several of these companies are going to be passing on the cost, right? We'll say the prices of those things that are carbon intensive will go up in comparison to things that aren't, which will relatively be less expensive. Businesses and all manner of folks in the middle of the economy are going to suddenly say, well, okay, I want one of those lower carbon content products or services then. And so that is the way that this stimulates individual freedom and innovation throughout the economy to respond to that change in relative price of goods and services. Okay, so I think I hope that I've gotten you partway at least to explaining that a revenue neutral carbon fee and dividend with border adjustment is the biggest policy tool, and that's what the economists say, to affect carbon mitigation and bring down CO2 levels. But will this be enough to stop temperature rise? Okay, here comes one of the most difficult parts of the presentation and tricky parts of the presentation. Here's what will happen to the cumulative CO2 emissions levels if we reduce annual emissions by 10% every year for 20 years. And if you see this down on the bottom, the level of annual emissions is just over 36 billion tons, as I said earlier. And this is global. And this is the excess level that takes us to the present level of 424 plus or minus parts per million of CO2 in the atmosphere. So the annual additions are a lot less than the global total. But even if we take down, even if we're successful with our mitigation strategies and taxing on carbon to bring down that level by 10% per year, we are going to be increasing in the aggregate by another 33%. This curve is the exact result of taking our starting point, subtracting, or just adding what has been now less and less each year, if we succeed in making it less and less each year. So we're going to be over 550 parts per million in the 2040s. If we already have these outrageous temperatures of air and water at 424, what is going to be happening when it's 550 plus? So we have to do something in addition to the mitigation and the reduction and the conversion to cleaner sources. And the International Panel on Climate Change has said the same thing. The IPCC has said the pathways that limit warming to 1.5 degrees require carbon dioxide removal, not just reduction of adds, but they require removal, CDR, carbon dioxide removal. And this leads some to say, well, we need not just to mitigate the pain, we need to restore climate to that safe harbor level. Remember, I showed you that for 10,000 years, we were averaging 280 parts per million, always over 300, I'm sorry, always under 300 parts per million. There's a big story to be told about sustainable population, not stopping what we have, but let's say reducing to the level at which Italy is replacing its population with about 1.3 babies per fertile woman. That's where Italy is. If we did that, we would have a much lower and more sustainable level of population on the earth by the end of this century. And so various scientists, again, Jim Hansen, Michael Mann, others, hitting net zero, that is just when we levelize the adds with the subtracts, isn't enough. We've got to restore the climate. And I'm here to say that climate restoration is possible. There are technologies, there is finance that we just need to goose into higher levels and scale them up. We do need to do something really huge, which is to remove, excuse me, in the aggregate, 1 trillion tons of CO2. That's 10 times what nature has done. Excuse me. I'm sorry, I just said that wrong. That has been done by nature 10 times in the last million years, over much longer periods than we need to do it. But we can do it too, using biomimicry. What do I mean? Nature's two major ways on a big scale to remove CO2 are ocean photosynthesis and limestone. The oceans, 72% of the surface of the globe, actually produce about half of the oxygen that we breathe. All those wonderful forests that we have in northern New England aren't the only source of oxygen. It's phytoplankton. And if we have ways of growing phytoplankton and utilizing the excess carbon dioxide to put into concrete the same way that oysters have done forever, we can start to actually pull the carbon down and sequester it in permanent ways. These are the kind of permanent, scalable, financially viable methods of doing that reduction of the legacy levels of carbon dioxide. Ocean iron fertilization, I can talk about that some more. Synthetic limestone, I will. Seaweed precipitation, there are several different companies that are working on growing more seaweed, using it for different products, but also sinking it to the bottom. We haven't talked about, and I'm not going to talk about methane oxidation, but that is definitely a large-scale thing that needs to be done, and I've just remarked on population. Now, what's happening in the political sphere? Well, a Republican from Maine and a Democrat from Washington got together and wrote the CREST Act, the Carbon Removal and Emission Storage Technologies Act, last year. They reintroduced it this year. They've gotten quite a bit of attention in, I would say, conservative settings for the value of doing additional research. And there also are a number of other senators, again, an independent, a Dem, a Republican, who have joined these women and have co-sponsored the CREST Act. This is something that anybody on this call can write to our members of Congress and say, hey, support the CREST Act. It is bipartisan, and it will start the ball moving. There's an even bigger bill that's been introduced. So far, it only has Democrats behind it, but it's been introduced in both the House and the Senate. It's called the Carbon Dioxide Removal Research and Development Act. In the House, it's New Yorker Paul Tonko and Californian Scott Peters, plus a bunch of others, including Ann Custer from New Hampshire, who are co-signing this piece of legislation. And, there is, I would say, a Republican, a conservative climate caucus in the U.S. House, which has 81 members in it. It's almost twice as many as in the Freedom Caucus. And that conservative climate caucus is all about expanding knowledge and information and thoughts about what is the best way to go. I've got to believe that because of their mission to expand thinking, that they will be behind the research and development that's proposed here. The Senate has a number of people, including our neighbor from Vermont, Peter Welch, who are co-sponsors of this Carbon Dioxide Removal Research and Development Act, which I think is a key. There's other keys out there, but this is really a key that we have to get moving. All right, now Lynn will be happy that I am doing a couple of these slides. Healthy forests are absolutely a way to sequester carbon, and the more diverse in species and in age range, the more sequestration happens in relatively fast timing of carbon dioxide in the fibers and in the soil. All a very good thing. Trees absolutely should be planted. We need more trees. We could use more dense trees in existing timberlands, but also in agricultural lands and non-agricultural lands, the lands that have been previously disturbed. We need more trees in urban territories to get rid of the heat islands and improve the air and outdoor living quality in urban areas. There's a couple of problems, though. We don't quite have enough land surface to do the mathematical job of reducing that huge amount of carbon dioxide that's already there. We don't have enough land. And there's another problem, too, which we have seen as we looked at the pink skies overhead this summer because of all the wildfires in across Canada and to some extent the American West. So trees have an unfortunate vulnerability to when it gets excessively warm and dry, and there are more and more warm and dry months and weeks. There will be more burning and there will be more releasing of their carbon dioxide back. Okay, a couple of people have asked me, well, what about direct air capture? I understand that that's a new thing and that's taking off. And yes, it is a technology, pulled the carbon dioxide directly out of the air. This is an Icelandic installation called Climeworks. And it is succeeding. It is pulling it out of the air at quite an expense and not at a very high level. 4,000 tons a year, not the level that is needed. Because we've already had more than 36 billion metric tons of added CO2, we would need 9 million of these installations in order to do the job of just taking care of what we're adding, just to get us to net zero. And that's a very expensive proposition. Now, iron, as it turns out, is a limiting nutrient in the ocean. It is often naturally added by volcanoes and also actually by wildfires and desert dust. And there have been numerous, I think about a dozen, a little more than a dozen tests of this in the ocean, spreading form of iron dust. Phytoplankton almost immediately, within hours, begin to flourish. And then zooplankton, and then krill, and then bigger fish, and even whales that eat that krill. And those little creatures, when they die, and the big creatures too, form abyssal snow that falls and adds to the ocean floor. And that could be a major scale method of restoring the climate. It would only take a small fraction of the surface area of the oceans, but it's a big job, but it could be paid for to some extent by the increased health of fisheries. So look at ocean iron fertilization. The White House has actually got a special study group that had just started about 2 weeks ago to pursue this and other ocean solutions. Now, limestone, limestone, like the White Cliffs of Dover, is it's created by the shells and skeletons of sea creatures. And the great majority of carbon that is secured or sequestered in the earth is actually in this form, created by oysters and other. And so if we start making synthetic limestone and also curing cement with carbon dioxide, that can lock it up for hundreds of years in roadways and in buildings and so forth, and form a particularly good way. Now, there are a couple of sequestration. There are a couple of businesses that are pursuing this. There's one in California called Blue Planet, which has already produced synthetic limestone pellets that were included in the aggregate that became the surface of a couple of new runways, in the San Francisco airport at the same cost as hauling the similar types of aggregate down from other spots to put it in. There's another one, Carbon Quest, which has got some really exciting projects, and Carbon Cure. These are companies that are innovating and putting quite a bit of thought into how to strengthen concrete and also sequester carbon dioxide at the very same time. Carbocrete is a Canadian company that's doing the same, putting it into cement blocks. And so if we build more with, let's say, carbon negative concrete and fertilize the oceans more, we can scale up these, let's say, human-induced but natural techniques. Well, there are funding solutions that have already been created. There's something called a Frontier Fund, which is these companies that have gotten together and pledged and begun to invest almost $1 billion in different methods of carbon dioxide reduction, the removal and reduction. And they have put money into a half dozen companies, and they're ready to do another round of other companies that are pursuing this thing. So this is part of the big solution. And I would say that in summary, it's not just reduction of emissions through conversion to other sources of energy and converting our transportation fleets. It's also reduction of the historic or legacy carbon dioxide that's up there and planting it in our buildings. And this is a reference to what I'm not going to talk about, which is enhanced methane oxidation and bringing that down. But we do need, it's a both and. It's not an either or. And those who are working avidly on carbon dioxide reduction always say we absolutely positively need more ways to reduce our dependence and reduce our additions, but as we do the reductions. So what can you do? You can sort of focus on both emissions reduction and removal of that legacy carbon dioxide by doing any one of these things. And all of these things will be effective on a local scale, on a personal scale. You can, I would welcome you to join the Citizens Climate Lobby on that biggest solution of mitigation. And to change the way New Hampshire in particular requires utilities to utilize renewable energy and encourage them to be leaders and not resistors. We haven't talked about it, but absolutely eating less red meat is a way to reduce your carbon footprint individually. And these are the sort of some of the other immediate local actions. I see that Gabrielle joined the call, and say that support community power, which is a way to get control over our production of electricity and to save money at it, and to save money for potential additional additions of investments in alternative generation, alternative to fossil fuels. I'd say write the local member of Congress and tell him to support both climate mitigation and restoration bills, as his colleague from New Hampshire already is. And then ask New Hampshire to do what the states of New Jersey, New York, California have already done, which is to say, you need to use, whenever you use concrete or aggregate, make sure that it is a type that incorporates carbon dioxide in it. It will make it stronger and less expensive. Open Air is a fantastic nonprofit that will teach all about those techniques. And Methane Action, you can learn about what I didn't talk about. Carbon 180 is another great one. So I've left maybe a few minutes for us to have some discussion here, and I hope that you'll stick with me and we can do that a bit. I'm going to stop sharing, and Russ has his hand up. You can unmute yourself.
I will do that. I'm flabbergasted to hear you mention concrete, because concrete has been falling in or growing in disfavor for years because of the amount of energy it takes to produce.
Right.
So on balance, are we sequestering more than we're producing? With this is just so foreign to anything I believed to this point.
Right, and you're absolutely right. Concrete globally is about a source of about 12% of our fossil fuel emissions. A lot of that is in the heating up of the Portland cement component. Right. Interestingly, and the Smithsonian Magazine published a piece about this. Folks have analyzed, why is it that some of the Roman aqueducts and Roman walls have lasted for more than 2,000 years, which is about 800 years longer than present concrete makers say that such structures should exist. It's because they have limestone and lime added into the mix of the mortar of the concrete in those old structures. So it does make it stronger. And yes, if you use enough carbon dioxide in the making of the Portland cement, you can reduce the amount of Portland cement that is needed, and you can reduce the temperature that's needed, and you can strengthen the final product. And then if you also utilize artificial limestone, synthetic limestone made from the fly ash, you are reducing a source and you're putting it and sequestering it into that use. It is not, let's say, it is not an obvious net benefit, but we're already spending. Concrete is the most used building material in the world. So we're already producing and using that. We're going to be continuing to use it and produce it. Let's produce it the right way and help it be part of the answer. And it's an economically self-sufficient way to do that. So I'd be happy to send you additional ways. But look at Blue Planet and Carbon Cure, and just look them up on Ask the Google, and you'll get some good starting points.
Peter Dugas just did a presentation at Tin Mountain here very, very recently, and he used the MIT system to show just how effective the carbon tax was going to be versus everything else, insulating and driving electric vehicles and all that stuff. So you guys are right on the same wavelength. Apparently, you're probably working together.
We are working together. We're about to be on a call with our Senator Angus King's Chief Environmental Officer in a week or so, and continue the conversation that we have previously started numerous times. We have a very, very good relationship there, and Peter's become one of my best friends here in Maine.
I just point out that the newest Green Energy Times are here. One of your residents, Alan Phoenix, picked up several bundles today, so he'll be distributing them around Tamworth.
Good, because it's an article that quotes Gabrielle quite significantly in it. Yes, Tamworth is one of about 40 towns in the good state of New Hampshire that have decided to sign on with the nonprofit Community Power Coalition of New Hampshire, because it really does look like a way to save money, go greener, and control our own future. And I think it will be some exciting things. If town meeting passes it next March, it will be kind of exciting. Ted, I see Ted and Gabrielle on here. If you have anything else to say about that, please do, or we can take the question or comment from Paul King.
And do you see
Paul?
Yes. So with increased home heating and transportation being electric, you didn't mention the grid at all, but how much do you think the grid needs to expand? And why not spend carbon tax on the grid, improving the grid?
Yeah, and Paul, there are two very good points and issues that you have just raised, and you are absolutely right that we need to have an expansion of the grid and making it smarter. It is thought that if we succeed in doing everything that we are aiming to do with clean energy, that we're going to have somewhere between 20 and 30 to 35% increase in the amount of transmission and distribution infrastructure built, and that is something that absolutely we need to be prepared to do, and do it in some cases in ways that I think will be defensive of environmental standards, but also recognizing, let's say, the necessity to go in the clean direction. And let's see, the second part of your question was, should we put carbon tax for that? You know, there are a number of different, let's say, virtuous things that we could put the carbon tax proceeds at, and it would be very good for certain industries. For 13 years, I was in the solar industry, and there were a number of people in the solar industry who said, okay, you want a carbon tax? Well, let's have it go into solar. I know. I'm not asking for everybody here to endorse a policy that will help me. I'm suggesting that we endorse a policy that will help everybody and help everybody's pocketbook and freedom of choice. And people are smart. People will, on average, if they start to discover that these garden products that are made with oil-based things are going up in price, and these garden products that are organic are going down relatively in price, I'm going to go with the less expensive and lower carbon content products. And that's going to happen over hundreds or thousands of different industries. And also there's the question of making sure that we get consensus. And Citizens Climate Lobby has long considered doing something, as you suggest, some virtuous reuse of the money that's collected from the polluters. And over again, we come back to, let's make sure this is democratically defensible, that we don't create what Emmanuel Macron in France created a few years ago when he just increased gas prices and said we're doing this for climate reasons. And there was a big revolt. There was the yellow vest posse everywhere, and people, he almost was voted out of office as a result of doing that, because it was purely an increase and not a sharing. So that's what our philosophy is. If you disagree, get into the debate about how the law should be written, and we'll talk about it.
David,
Any other questions? What?
there's a question in the chat. There's a note in the chat. Folks should know that the Tamworth Pursuit of Community Power is featured in the recent issue of Green Energy Times on page 12.
Yes, it is.
Question: could you talk a little bit about methane as a significant contributor to climate change?
Yeah. Well, methane, CH4, not CO2, but CH4, is a very significant contributor to climate change. It's different from CO2, but it is, although it is thought somewhere between 70 and 80 times as bad as CO2 per ton of methane that's up there as a greenhouse gas, raising temperature. It only lasts 2 weeks, 3 weeks in the atmosphere, and then it tends to oxidize by the sun and by other things, dust and sun. And so it actually can be precipitated out if we were willing to undertake methods that are known of helping that oxidation by the sun of the methane content. But it's particularly, I would say, a couple more things. Number one, the Inflation Reduction Act actually put in place for the first time a price on a greenhouse gas. They put a price on methane. They put a price on methane that's released by drillers and by pumpers of methane. And that, we'll see. I mean, we should watch and wait and see how that affects the production of methane. There are many, let's say, gas drillers who simply burn it off and flare it off into the atmosphere. So there is already, let's say, a solution that is perhaps in the works. Excuse me. And yet we need a much bigger scale solution of treating methane. And the other issue is not let's say the man-released methane, but methane that's coming out of permafrost. And there are huge areas in Siberia and in Alaska, and I think Canada, where permafrost is melting at uncommonly fast rates. The temperature change that we experience is 3 times as much change in the northern reaches and the far southern reaches. That's why the polar regions are changing faster than we are. They're not getting hotter on absolute terms, but the change is much greater. That's 8 or 9 degrees already instead of 1. And so when permafrost melts, methane gets released, and it is feared that if we really melt a great deal of that, particularly in near oceans, let's say north of Siberia, there could be methane bursts, which would release ginormous amounts of it into the atmosphere and change the greenhouse gas mix very quickly and really heat things up very fast. So there's anxiety about that. And I would say look up methane action, which is taking a number of steps, and it's just a much too big a topic for me to get into, and I'm not a chemist either. So let's any other comments in the chat, or I see that
No.
there's like 5.
Want to just ask you one other question, which is when you talk about asking New Hampshire to increase RPS, and what are ways for people to do that?
Well,
You know, are particular people you think should be contacted? Is it just speak to your local?
well, our local state assembly members and senators are the ones that need to be pressed to take action and boost us up to, let's get up at least to the level of the median in the Northeast. New Hampshire, Vermont, New Hampshire, Maine, Massachusetts, Connecticut are all connected in the ISO New England. We're all part of the same grid, and the leaders of all of those separate PUCs in each state meet on a fairly frequent basis, and we got to just. Unfortunately, the PUC can't by itself reset the standard. It's a state legislature that needs to do it. It wouldn't hurt to put some pressure on Governor Sununu.
Does anybody have other questions? Comments?
Point out, if anybody wants more copies of the Green Energy Times, I have a few thousand here. If you got any other places you'd like to see them distributed, Mary knows how to get a hold of me, and I do the local distribution. That's why I have thousands of copies.
Okay. And at the end of the day, they make great kindling.
Yeah. Almost as good as the Common Daily Sun.
Yeah. Now, Dexter, you were moving towards your unmute button. No.
I think Gabrielle, do you want to say something?
Yeah. Yeah, I wanted to jump in there on the carbon, methane question, because I think David said it lasts for 12 weeks in the atmosphere, and I think you meant years.
No, methane is a much faster cycling through the atmosphere.
So the International Energy Commission says that it's years that it lasts in the atmosphere. So it does matter that we reduce it, and a focus on methane reduction, which for us means our gas stoves and how we heat our houses, is an important part of what we can do as individuals for that.
Yeah. Yeah, and also there's the matter of indoor air quality. And thank you for that, Gabrielle. But the matter of indoor air quality, unfortunately, as we burn gas in our stoves, there are all sorts of things, including the methane and carbon monoxide, that we really shouldn't be exposing our kids to. Jim Diamond has his hand raised.
Hey, so yeah, I want to make sure I got my mute button off here.
Yep.
Thanks. This is terrific, Dave. So Gabrielle's correct. The lifetime of methane in the atmosphere is 12 years. That's just the kinetic stuff. That is far shorter than CO2. So yeah, eventually whatever methane we have will be oxidized to CO2, which is going to 90% of the CO2 in the atmosphere is going to disappear within 100 years. It's the 10% that sticks around for hundreds of thousands of years. That's the real problem. And that's why we see this residual CO2 level creep up and up and up and up and up. The oceans keep absorbing CO2, and there's plenty of stuff in the soil as well. And that keeps on reducing the amount of CO2 in the atmosphere. So our actual annual budget for CO2 production is more than the 36 gigatons that are added to the year net.
Mm-hmm.
There's far more. It's like more like 200 gigatons of CO2 that are actually produced and about 170 that are consumed. And you're right, methane's a really scary thing. And the place where it's going to come from are, first of all, tundras. And second, these benthic deposits of methane down below about 150, 200 feet in the oceans. So there, methane clathrates form. That's a compound that it's a mixture of methane and water that makes a regular crystal structure, and it's like snow. But it will dissolve and dissociate into methane and water at pressures less than about 10 atmospheres. So you don't have to go real deep in the ocean until that stuff is stable. And that's the really, really scary thing, is all these benthic deposits of methane clathrates. You can look up videos of this stuff. Fairbanks, Alaska, burning open lakes containing methane. Very, very frightening.
Yeah, I thank you very much for that contribution, Jim. That's very helpful. Lynn Flackus posted something in the chat, which, if I've understood it correctly, I should comment on the fact that buildings, particularly buildings that are made with let's say cross-laminated timber and just with wood, last a long time, and that is a different way to sequester carbon. It is, I think, it's an increasingly looked at source, as steel is more expensive and steel is much more carbon intensive in its production as is concrete. And if you can put together mass timber, pre-dried cross-laminated timber, you can build a taller structure, a strong structure that will last a good long time and look beautiful as well. So so there's someone who told me, if you must cut down a tree, do something beautiful with it. Lynn, did you want to say something more about that?
Yeah, I'm just curious about the whole carbon footprint of building solar arrays. I mean, I know it's probably minimal compared to the carbon footprint of burning coal, but I know there are things that are required to build the panel that have impacts on the environment, and I'm always struggling with how that fits in the big picture of things.
Right. Okay.
I'm looking for answers on the footprint, the carbon footprint of actually installing a solar array on a certain number of acres versus the bigger picture.
Right. Well, first of all, if you, I think the good data is found with the Solar Energy Industries Association, SEIA, but this very good question has been raised for the last 10 years or more. Okay, how much environmental degradation is done by the building of a solar panel compared to what its clean output is? And the answer has come up that it only takes about a year and a half or so of the operation of a solar panel to make back what the carbon cost of its creation was. And any of the good quality solar panels has a 25-year warranty attached to it. So if it's a 25 or 30-year product and it only took a year and a half to, let's say, pay back through the production of clean energy, the carbon cost of putting it together, that's a pretty darn good ratio. Solar, I went into the solar industry because when I wanted to do something serious about climate change in 2007, I looked around and studied around and evaluated around. Wind was not as well developed then, but solar had been. Obviously, solar took us to the moon and back, right? And obviously, much more expensive panels than that. But I determined that it was closest to being the A-rated answer to the burning of coal, oil, and gas, and should be the substituted method. Now, I am not an advocate of cutting down acres of trees and putting up solar. I think that's probably not a good idea environmentally. I think taking a formerly used and abused stretch of land, let's say a sand and gravel pit, a former dump, or a present dump, turning that brownfield into a greenfield by putting solar on it is going to be definitely a net positive in the long run. And this is partly why in the Inflation Reduction Act, there is a 30% reward to those who invest in solar, and it's a 40% reward to those who invest in solar that goes on a brownfield. That's an identified polluted piece of ground. So don't take prime farmland and put solar all over it. Take mediocre farmland, especially if it's got no trees around and it's south-facing slope. You're going to come out way ahead. Thank you for the question, Lynn.
There's another couple of questions.
Yeah.
Oop, another one coming in. Should we be concerned about methane coming from farms in our town? Are there some places that have better air quality than others? I don't totally understand.
I love the smell of manure, don't you? I don't understand that question myself, except, I mean.
Do you want to clarify that? Are there some places question? There's a question about onshore wind.
Now, do you mean offshore wind, or I mean onshore wind is turbines erected on the ground, and I would say that wind turbine energy generation is now the least expensive form on a megawatt by megawatt basis of energy generation in the U.S., and that's why several otherwise red states have totally adopted wind and defended and supported wind production because it can be economically very effective. The issue is that you don't often have excellent wind venues close to the places that are using the energy. So you then need to put a line in and transmit it to where the energy is being utilized. Now, offshore, the Gulf of Maine, this summer, the state legislature passed and the governor signed a bill essentially initiating the procurement of offshore wind. If you go out 20 miles, there's very few times when the wind is not blowing, and it's just a really solid, steady, wonderful, clean source of renewable energy, and it's not disturbing shorebirds. It's not disturbing, it really shouldn't be considered disturbing to anyone, and it is, I think, extremely promising. Some people have referred to the Gulf of Maine as the Saudi Arabia of wind. So what else?
I'm just going to read one more comment. There's not a question in it exactly, but here we have. I'm struck by how many of our problems are interrelated. You mentioned population growth linked to climate. Perhaps the greatest driver of population growth is inequality, or specifically poverty and or marginalized living. Having children is a poor family's hope for some care in their older age, a huge global problem. I have a teacher who calls these wicked problems because they're so entangled. Yes,
they are entangled. And, this is the reason why, I don't know how many of you remember the name Paul Hawken, Smith and Hawken, garden supply company from years ago. And Paul Hawken has been a writer and thinker for a lot of years. Well, in 2016, he wrote a book called Drawdown, and it chronicles 80 of the most active, most promising methods to reduce carbon dioxide in the atmosphere, and 20 more that are on that are right around the corner that should be invested in because they're very promising in the future. But the 80 are ones that are in place now and can be studied and analyzed. And 2 of the top 10 were involved with the education and liberation and empowerment of women. And it's been proven time and time again that when education is available and small business enterprise and other empowerments of women are possible, they figure out that they have another way to live and make themselves meaningful and not have a whole passel of children, and they find ways to succeed in life with and improve, let's say, improve the local economy at the same time. So if he took, is that the, I see book available to borrow in the Tamworth Library, the Drawdown, and there's an organization that's called Drawdown, and it's going all around the world and promoting their bundle of things. Now, when his book came out, excuse me, he was a resident of Marin County, California, where I lived at the time, and his book came out. We got a group of over 500 people together at a local university in Marin for him to present the book, present his key ideas, and then have Q&A. And I was the moderator, and the first question came, hey, of these 80, you've never mentioned carbon fee. You never mentioned carbon tax. He said, well, that's because it's a political policy. I want to reveal solutions and, actual sort of physical implementable solutions, and not policies. And several folks weren't happy with that response, but he is a big defender of, let's say, plant-based diet and of other important and highly, let's say, highly contributory things. Keeping in control the gases that are used for cooling was one of the very top things, because those gases are way worse than even methane in creating a greenhouse gas effect. Now, Jim, did your hand come back up, or is that a residual from your earlier?
No, I have another comment. So I am a retired chemist, and I actually taught this kind of stuff in my chemistry classes. I really like the idea of adding iron to the oceans. I think in terms of the things that we can do to the atmosphere that will have a quick and effective response within the atmosphere, adding iron makes a lot of sense. And I think we ought to be pushing for that. I didn't hear you discuss at all geoengineering, because I actually, iron is in the ocean is the only form of geoengineering I really like. The others I find extremely scary.
Yeah, I agree.
SO2 to the atmosphere, I think is a horrible idea.
I completely agree on both accounts. And if you hold on 1 second to get something. A year ago, I brought this author to Maine, Peter Fikowski, and he wrote this book. And I've recently given a copy of this book to the Cook Memorial Library as well. And it is, he enumerates several things, including population control. But the first one is ocean iron fertilization, that I had not really heard about, but have since heard an increasing amount about. It is one of the techniques that I did mention the carbon dioxide removal research and development laws, and both of those say that money should go into research and development of ocean iron fertilization. And I don't refer to it as geoengineering because it's using a natural process. Volcanoes have produced iron. that floats over the ocean. Mount Pinatubo, after Mount Pinatubo erupted, for 2 years after it erupted, the Keeling curve of that wiggly line of increasing CO2 every year, it flattened out and went down slightly. And so it shifted. So there was a permanent reduction and change in that curve of addition of CO2 or greenhouse gases overall, because of the iron fertilization of oceans that created a whole lot of
the chemistry is a little more complicated because there's water vapor and it goes into different layers of the atmosphere as well. But
Yep.
You're right. You know, volcanoes actually have a net cooling effect on the globe.
Yes,
I'm going to leave my
this
comment
was
there.
CO2. This was CO2 level, not just cooling. But you're right. If we have a whole lot of particles out there, that can also shade and cool the temperature of the air underneath. That's absolutely right. Let's see. Should population control occur primarily in high emitting regions? How would this work? You know, one of the things that one of the reasons that I avoided talking about population is that I don't like to talk about population control. When China ended its one-child policy, several different things happened. But one of the things that happened was that the birth weight went down. People don't like to be controlled about what they may do as much as, let's say, enlightened and enticed to do the right things. Population is obviously an extremely complicated issue, and it's tied in with religious values, so not to any light extent, but a very heavy extent. And even in Italy, which is, I said, their fertilization rate is exactly what we would need to have a steady reduction in the total population of the world if other countries adopted it. But I don't think you can suddenly say, legislate the number of children. You can inform, encourage, and maybe there are some incentives, but I think it's mostly a matter of letting folks know, and young people know this. I mean, the youth of the U.S. knows this absolutely, and that's why they've been having fewer kids, I think, and one of the reasons. So I'm not sure, Gabrielle, that I would want to implement a top-down population control rule, but rather a empowerment of women, education of girls, education of all youth, and bringing them forward to understanding ways that they can control their own destiny better by not having quite so many kids.
I think part of Paul Hawkins' point in that book is that when women have reproductive choice, there are lower birth rates than when they don't.
Yes.
Thank you so much, David.
Well, I've enjoyed this. I could go on for hours.
We can do it again. We can do it in person sometime.
That would be fun.
But
That would be
thank
fun.
you so much.